Hello friends, today I'm going to solve LeetCode problem number 232, implement queue using stacks. So in this problem we can use only two stacks and implement a queue. So here we are given the myQueue class in which we have the push method, pop method, pick method and empty method. Okay, so push method. Okay, let's first of all look what stack and queue are. Okay, so let's start with a queue. So in queue we have, it's basically a linear data structure in which we add elements from the end and we remove elements from the top. Okay, so let's suppose we have these values. Alright, so we have these 5 numbers and we want to add them from the end and remove them, right? So if it is a queue, so what will happen is when we add one, it gets added to the end. So since this queue is empty initially, so we add 1 and it becomes the first element. Next, when we add 2, it is appended after 1. Similarly, when we add 3, it goes after 2 and so on. Okay, so now if we want to remove an element, we can only remove from the front. So from the front, what we have in the front is the value 1, right? So we remove the value 1. Okay, now our front only has the value 2, right? And if we want to remove, we can remove only the front element, which is 2. Okay, now if we want to add one more element, then basically this is the front right now and this is the end. So the end has not moved yet. End will only move if we add an element to it. So now we added an element to it and now our end has moved from 4 to 5. Okay, so this is how it looks, and we can also perform one more operation on our queue, which is pick method. So pick helps us, pick is used to see which element is in the front of the queue. We do not remove it, we just look at the element and get the value of the element. Okay, in pop we actually remove the element from the queue itself, but in pick we just get the value of the element and our front will not move. Okay, so our front will still be at the same position. So this is about queue. Hence queue is also called first in first out. Okay, because the element which was first inserted is removed first, right? So that's why it's called FIFO. And now let's talk about stack. So stack is also a linear data structure, and if we are adding these 5 elements in our stack, so it adds from the end. Okay, so it's going to add from the end and it is also going to remove from the end only. In case of stack, we added from the end but we removed from the top, right, from the front. But in case of stack, it's different. We add from the end and we remove from the end. So if we're adding 1, we add 1 and next we add 2, after that we add 3, and now if we want to remove, we remove 3. Okay, so our front pointer and end pointer, basically the top, we only keep one pointer, which is the top, is now shifted to 2, and if we add next element, it becomes equals to 4. Now if we remove the element, okay, now our top is again moved here, so it moves from 2 to 4 because we added one more element. Now if we want to pop an element, then we pop it from the top. Now our top is again moved to the next element, which is 2. Okay, because these 2 elements have already been popped out. So basically this is last in first out. Okay, because the element which we added at the last was removed first. Like for example, if we add 5 next, then what happens is our top now becomes here, right, it's pointing to 5, and if we want to remove, we remove 5. So 5 was added at last and it was removed first, right? So that's why it's last in first out. Now to implement queue using stack. Okay, so what is in queue is that we remove from the front and we add from the end. Okay, and in case of stack, we do it from only one end. So now we need to keep, we are only keeping track of one pointer, which is top. Here we keep track of front and end, so we need these two pointers, right? So for that we are going to implement the queue using two stacks. So this is a queue, so we are going to implement two stacks, stack 1 and okay, and one more stack, which is stack 2. Okay, so in stack 2 also it's the same, we add from the end and remove from the end, that is top. So now how are we going to implement that, like how does it actually work? So let's see. So let's suppose we have the element 1, 2 and 3. Okay, so I'm only taking these 3 elements. So if we are gonna push these elements, we push it to stack 1. So we push the element 1, we push 2 and we push 3. Okay, so if let's just also assume that we have the stack. So in case of stack, all right, it's equals to 2 over here. So if these were a queue, okay, so we have a queue and we have a stack S1. Now if we want to remove in queue, we remove the first element, right? So we want to remove the first element, which is 1, but here we cannot access 1 because we only can access the top element, which is 3. So what we do is we take all of these elements and push it to pop all the elements from the S1 and push it to S2. Okay, so what happens is when we pop the last element and we push to S2, so the last element becomes the first element here. We pop the next element from here, okay, which becomes the next one over here, and then we pop 1, which becomes the top element here. Now 1 is the top element, so now this top pointer is pointing to 1. Okay, so in this way we can pop this out or pick the element from our stack. Okay, so in this way we can use two stacks to pop and push, pop and pick elements, okay, in our queue. Now next thing to check if the queue is empty or not, what we do is we just need to check if S1 is empty or not. Okay, if the length of S1 is empty or not. Okay, so once we have popped out, we'll again like push the remaining elements to S1. So next what we'll have is we pop out the top, which is 2, so 2 is pushed first, and then again we pop out 3. So 3 is the next element, which is the top element over here, right? So in this way our S1 becomes this, and in this way we are able to implement queue. Okay, now I hope you understand what this problem is about and how we can solve it using two stacks. Let's start diving into the coding. Okay, so we need two stacks, right? So S1 equals a stack, and then this dot S2 is the next stack. Okay, now what we need to do, we need to push, right? So we are just pushing it into stack 1. We can simply push it, we do not have to do anything. Only for popping now we need the two stacks. So from stack 1 we pop all the elements to stack 2. So while this that stack 1 that length, so while the stack 1 is not empty, we are going to pop all the elements from, okay, we are going to push to our stack 2 what, the elements in stack 1, right? So we pop all the elements from S1 and we push them to S2, and then we take the front element because we need to return it. So the front element, which the front of the queue, which is the top of the stack S2, right? So S2 dot pop, so we pop from the S2, and then finally what we do is we push remaining to the S1 stack. So while S2 dot length, this dot S1 dot push, so we are going to push our S2, okay, and finally we are going to return our front element. So in this way we get the first element from our stack using two queues. Okay, first element of our queue using two stacks. Now we have implemented pop. Similar way we are going to implement peak. So I'm just going to copy and paste everything over here, and here we do not pop. Actually we just need the last element. We are only looking at the last element, right? We do not remove it, so we do not use the pop function, and that's all about it. And here we just return if this dot stack one dot length equals 0. Okay, now let's try to run this. So what's wrong? Front is not defined. Okay, this, it's not this, it's let. We need to define a local variable. Front is a local variable. Awesome, let's submit this one. Great. Now talking about the time complexity of this solution, since we are here in case of push operation, we are only pushing at the end, right? So we are not doing any additional operations, so it's constant time complexity. Now about pop, we are taking all the elements and pushing that element to a new stack, right? So it's O of n time complexity, and this is also of n time complexity, so the overall time complexity of pop is O of n. And same goes with the peak operation, and this empty function is constant time complexity. And talking about the space complexity, since we are using only stack S1, we are using 2 stacks, okay, and the length depends on the number of elements in the stack, so it's O of n time complexity overall. Okay, so that's all about this solution. I hope you liked it. Please like and subscribe to my channel for more videos, and thank you so much for watching till the end.